with Sara and Sean.
Hey everyone, welcome to Graph Time with Sara and Sean. I'm Sara.
And I'm Sean. Sarah and I make animations, games, interactions, and we do it all using math in the Desmos graphing calculator.
Yeah, and before I started doing graphing more regularly, I really only used Desmos to graph lines and curves and stuff when I was a math teacher with my students. But when I started learning more about the graphing calculator, one thing I explored a lot, which was really fun, was making and altering a grid of points.
Yeah, it's a pretty fun thing to do. I don't know why I like it so much, but it's fun to just like have all this control over a lot of things at once and just to like play around and animate things. Just a couple of examples of what we're talking about. Here's one I made a super long time ago with fireworks, where there's like different pattern fireworks going off, which was pretty fun to make. And another example here, which I made more recently, which is just a bunch of points that kind of I just kind of vibed out a fun pattern for them to go into. And it's, as you watch it, it's sort of, they line up into different patterns as it animates. So we're not going to do either of those today, but it is a very fun thing to do. Sarah's going to guide us through a bit of an example. Take it away.
Yeah, so if you were like me, even though I do a lot of graphing, I just saw those things that Sean put on the screen and I was like, oh my gosh, that looks so intense. Like, can I do that? I was like, whoa.
Yeah, definitely a thing I've learned as I've graphed more and more is it's really super hard to look at what someone else did and understand it right away. And some of that's just like how they named things and how they thought of it. But, we want to make things as approachable as possible. So, do your best just to like pull out pieces of this that might be helpful to you. Try to learn a thing or two. We'll put some links in the comments so you can scroll through at your own pace later, take a look at all the expressions, but try not to worry too much. If you don't understand what something means, we'll give you the link. You can play around with it yourself, see how things change as you change numbers, and probably learn a lot that way.
Yeah. Okay, so let's start with plotting points. So I'm going to start by doing something that list comprehension is what it's called. I'm going to plot all of my points in one big list, a bunch of X and Y's. And maybe I want all of my X's to go from like -7 to -7 or something like that. So I can make a list of like, these are all my X's. I can say I want all my X's to go from -7 all the way to 7. And this is going to go like -7, -6, and it'll count by 1. And I'll do the same thing for my Y's. And now I have 225 points just on the screen. All of my X's are going from -7 to 7, and same for my Y's. And maybe I even want to call this list P. And yeah, jump in, Sean.
Yeah. So it used to be really a lot harder to do this, but now, if you type it in that certain way, if you use for and the comma, it's going to lay out the whole list. Can you say a little bit more about like how exactly this works? Like what am I getting with P?
Yeah, that's sometimes I don't know. I look at it and I'm like, that's what I get. But there are a few ways for me to tell. One, now that I see all of these listed out, I see like -7, -6, -5. It's indexing through my first list and it's going through all of the X's with the first Y. Another way to see that, if I wanted to, okay, this one will be, I'll make it a star so you can see. If I wanted to see the elements of my list, let me make it a big star so we can really see.
Love that.
Isn't even as big as whoa.
Okay, too big.
Okay, so I expected the -7's Y to stay and for me to go across the screen.
All right, so what I'm looking at here, we've got capital P.
Mm-hmm.
Capital P represents a whole bunch of points, right? And
Yes.
and basically it's taking all those x's. So it's taking like -7, -6, all the way to 7. It's taking all those x's, it's matching them up with every y. And then when you take all those x's and all those y's, put them together, we get this.
Yes. Exactly.
And on that second line, you're just kind of looking at them one at a time. So you can see like, I can never remember which order it is, if it does the x's first or the y's first, or the first thing first or the second thing first.
Yeah. Okay, so I'm thinking one thing that could be cool is maybe all of these points are black, and I kind of want to make a flashlight that turns them yellow. Or maybe we start with a movable point and we drag it around and we change the points in some way. It could be a flashlight, it could be their colors. What sounds more exciting to you, Sean, right now?
Oh, I have 2 ideas. I can't decide. We can maybe do both. I'm thinking color seems pretty fun if the colors change as you move the draggable points, but it might also just like add like a little bit of pop if the size of the points changed a little bit. So it kind of like bubbled up, if that makes any sense,
Yeah.
as it's close to the movable point.
Okay, I'm gonna make a movable point. I'm gonna call it move. Fun fact is if you name a point, it's just gonna be movable. Okay, I can drag it. I have a movable point. First thing done. Okay, let's do the size first.
Yeah.
Okay, so they're all gonna have a different size. And wow, there's a lot of ways we can think about the size. The closer it is to the point, we could make it smaller.
Yeah, I
Yeah?
like thinking about like the distance to the point. Sounds pretty cool.
Uh-huh. Okay, so why don't we gather all the distances? I don't even need to calculate them with the distance formula because it just exists. And if I take the distance, I can get all of these points and calculate 225 distances by taking the distance between my entire list and my movable point. And now I have all of these, and you'll see these numbers change as I move my point because it's updating every time I move my point. And I'll call this distance. And now we can remember. So let's make sizes based off of their distance from the point. Maybe the simplest thing I could do is see what happens if I just put distance inside of the point field. I don't know what's going to happen.
Yeah. Yeah, so that's how big a size the size of a point is. So make the
Yeah.
size of distance. Honestly,
that
I
actually
can't
was,
believe that's pretty good.
I know. I'm actually shocked. I was like, okay, I haven't really prepared this. I don't really know what I should do.
I thought we might have to do some more complicated math, but turns out it's actually pretty awesome.
That actually is really awesome. If we wanted to reverse it and I kind of like it like this though. I don't really want to reverse it.
Yeah, I thought it was gonna be cooler the other way, but I'm into it. I think that's enough. Maybe we
Me
just
too.
do color.
Okay. Yeah, if it's not broken, don't fix it. Okay.
Yeah, so all Sarah did there was make the size of the points equal to the distance between the movable point.
Yeah. So that means if it's really close to it, the distance is like 0. And the furthest I guess if I zoom out and I move this point really far away, then the
Yeah.
points could get really big and if we wanted to, let's say, cap how big it is, the sizes, we don't even need to. I like it. Should we just move the
Yeah.
color?
I have one idea, which I'm not sure is gonna make it better or worse, but I'm kind of interested to see what happens. Like
What?
right now they get to be 0, but what if we did 1 plus the distance? What if we just added 1 into the distance?
Sure. Let's use this then. So you're saying 1 plus the distance.
Yeah. What if so that would just make it so like instead of going to 0, we're going to 1.
Great.
And it could be cool or it could just be worse. I don't know.
Yeah, no, one is
It's
still like,
basically the same.
it's
Yeah,
pretty
it really
small.
almost doesn't make a difference.
Yeah, you can see 5 makes a
Oh,
big difference, but I
yeah.
kinda like them pretty small.
Yeah, okay. Not better, but interesting.
And if we wanted to have let's say the max we wanted to have was like 15 or something, I could set a max. I think I can do that by always taking the minimum of whatever this is and 15. Oh, but it actually looks so much better without this.
Yeah. Fir First graph, best graph. Turns
Yeah,
out.
that's actually pretty crazy. Okay, I like what we have
Yeah.
going. Okay, let's change the colors.
Yeah, I'm excited about that. I think that's gonna be really fun. Wait, Sarah, I think it's time we turn off the grid.
Okay, you're right.
I just wanna focus on this art.
Yeah. Okay. It's gone. Oh, it's already
Nice.
so much better.
Nice.
So I was really excited about colors, but I feel like grayscale could also be. I'm pausing because
I knew it. I knew
the
it.
street sweeper came by, everybody, but that's fine. Okay. Let's make some colors. Colors. And I'm making a list of colors because I want a lot of them. But let's start off with a single color. We've talked about hue, saturation, value before. And you have to give it a name or else the calculator will get mad at you. And let's say for the hue, it goes from 0 to 360. So I'm just going to type in 50. I just picked that like totally randomly. Saturation.
What color is that though? I bet you know what color 50 is if you
So
search your
it
feelings.
goes from red. I feel like it's I don't know. I don't know what's after red in the color wheel.
Yellow? No. Orange,
I bet
yellow?
it's green. I bet it's a yellow.
It's probably
I bet it's
yellow.
almost green. Okay.
I really don't know though.
It's yellow.
Wow.
Okay. Yeah.
That was a guess.
So the things we want to change when we're changing the color in this space are the hues. And a fun way we could change the hues if we're using this distance. I'm actually really excited. So if let's say we want to go from 0 to 360 for all of the colors. A way I can do that is by taking every distance and squishing them to be between 0 and 1.
Yeah, okay. But so in order to do that, I think you would need to know what the biggest distance is right now.
Yes.
So how
Lucky
do we
for
do that?
us, we have a function called max, and I can take the max distance and it will give me the biggest distance is 21 and it will update it from all my points. So it's always giving me the biggest distance in that list.
Okay, so like distance is gonna go to 20, but we want the color to go to like 360.
Sure. Yes, the biggest color should be 360. Or sorry, the biggest distance I'm expecting to be red. So what I'm gonna do is if I want the biggest number in this list to end up being 1, I can divide this entire list by the biggest number in this list. I'm gonna give it a go.
Whoa, whoa. I thought you were just gonna divide by 20. I'm interested. This seems better
Oh,
though. This seems better.
yeah.
Yeah,
If I
okay.
look at this is kind of crazy. But if I look at my list, they are now all decimals between 0 and 1.
Gotcha. Okay, at the end, let's run it back and see what happens when we put 20 in, but I'm excited to see
Oh my
what this
gosh.
does.
Can I disappear that? Yes, it disappears. Okay, but I'm not quite done yet because I actually want these to go from 0 to 360. And right now they're going from 0 to 1. So I'm going to multiply this. by 360.
I guess a nice part about this is you're never going to go over 360.
I'm never going to go over. And
And
I'm
if
going
we
to
just
call
put
these my
20 in,
shoes. You want me
if
to
we
make this 20?
no, I said if we had put no, sorry.
Oh,
I said if we had put 20 in, we might like wrap around. I don't but once we see it, we'll see what happens.
okay. Nothing's going to happen yet because I see some colors here, but I'm going to make it a capital C. I'm going to go back to my points. Are you ready? There are my colors.
Whoa.
Oh. And there are some colors.
Now here's where I might want to have like a bigger minimum point size because I feel like it's hard to see some of the colors because they're so small, and you like never see those colors. So maybe we want to, yeah, like I didn't even know there was orange in there.
Oh, yeah. Another thing we can do is make our points more dense if we want. So instead of counting by ones, we can count by like halves. That'll make it
More
a
points.
lot
That'd be cool.
denser. I don't know if it's gonna like break everything. So a way you can change the way your list counts is just tell it the next step. So this assumes it's going to 1, but if I actually want it to go to negative 6.5, all I have to do is add a negative 6.5.
Now, if it were me, I absolutely would have typed negative 7.5 and then remembered how negative numbers work. So like, I'm kind of an expert in the Desmos calculator, but that is 100% what I would have typed in that situation. So I'm
Whoa,
proud of you.
thank you. This is almost an optical illusion.
Yeah, that's actually kind of sick.
Okay, it's fun that it's a circle because, and I'm like, what? In my brains, I'm like, why did I make a circle? And because the distance goes out in a circle. All the set of points that are equidistant away from my movable are in a circle. So that's pretty fun and cool.
Wait, I have some just crazy ideas. Are we allowed to just like throw some crazy ideas at this?
Throw some crazy ideas.
I'm curious what would happen if you put in the size line a square root on the distance.
I'm also curious. Okay, I'm gonna raise it to the 1/2. That's the same thing. No. I'll square root. I just gotta move it.
Oh, that is, I think, the exact opposite of what I wanted to do.
Well, the colors are. Wait, what's happening?
Yeah, so the size. Whoa.
So
Yeah, so I guess what I was thinking is it would like square roots kind of are shaped like they start really fast and then they slow down a lot. So I was thinking that it would make the points closer in size, but it didn't do that. I don't know.
yeah, I think what's happening is I think it grows quickly between 0 and 1, but if they're further or between 0 and 5, since I put this 5 here, but if they're more than 5 away, then they start being a similar size.
Yeah, I think it actually did kind of what I said. It's just it just doesn't get like the very close to middle points because they're still pretty close to 0. But like the green ones, I think are bigger. Wait, delete the square root a second?
Whoa.
Oh no. Huh. Yeah, I don't know. This is the opposite of what I expect. Probably probably squared would be. What if you squared it? I feel like
I
it's
also
just
have
gonna
this
be
5 here, but
be
it's so
too
we can
big.
really see what's going on. Whoa.
Whoa, okay. All right, never mind.
Wait, this
Whoa, what is
kind of
that? What?
wild.
That is okay.
I'm into it. I think
Amazing.
we did something cool.
Didn't mean to do that at all. Happy little accidents.
Okay, I love it. Let's go back.
Yeah, let's go back. Let's go back.
Okay. Now I can't unsee what I had previously seen though.
Yeah, that was wild. And I don't know why that happened. We could probably we figure it out if we thought about it, but
Yeah, we certainly could.
yeah. What about that blue? Like there's so many beautiful vibrant colors. Not loving the blue movable point. Can we just change that to black?
Oh, yes.
Something like that? Unless you have a better color in mind.
One?
Yeah. Yeah.
Yeah.
Nice.
No, I think there's also like, let's say we wanted all of this to be a shade of blue instead of like
Whoa.
all the colors. So I don't actually know what color is
Okay. We got
blue.
red. Oh, rainbow. Red. Orange. Yellow.
Oh, wait.
Blue? No, green, blue.
Maybe it's like 260 over here. I don't know. I'm guessing. Let's see. Oh,
Okay, I feel like it should be 5/7 of the way, right? If we're following Roy G. Biv. I don't know if it works that way. Oh no.
okay.
6/7? 4/7? Where's the blue?
Okay, here's a blue.
Okay.
And if we want this to be shades of blue, so I think the value might change the shades. It's like how much shadows on it or something. And if we just want this to be the thing that's going from 0 to 1, then I can take my already 0 to 1s that I have and put that in here instead.
Whoa.
Kind of fun. So the closer it is, okay. So I'm also understanding how colors work now.
Yeah,
Like
so it's like it's
more light the further away it is.
yeah,
Like,
it's getting lighter the farther the distance is away.
uh-huh. Oh, this is fun. Okay. Now I understand a little more about value. Maybe I want to undo that and go back to 0.8. And let's see what saturation does. Oh, it's like grays. So the
Yeah, it's
further
all
they are.
yeah, saturation's like it starts out gray and then it becomes more and more of the hue as you go.
Yeah.
Cool.
Okay,
All right,
cool.
let's go back to the OG, the rainbow one.
Yeah, that was fun.
Yeah. Super fun.
Super fun. All right. I feel like we landed in a place that is like pretty cool. And Sean, I feel like why don't you close us out with some words of wisdom?
Yeah. So I think a lot of times you know, when you think about math, you might think that like making mistakes is bad. And I don't know if you noticed, Sarah and I made a lot of mistakes. We found a lot of happy accidents. A lot of things happened that we either didn't know what would happen or we didn't like intend to happen. And mistakes are just so important in math. They're how you learn. And we make, I would say, hundreds of mistakes whenever we make graphs. But we also, Sarah and I feel like especially tend to just barrel headlong into things that we don't understand. And we just try them and see what happens. Plug some numbers in, see how it changes. Encourage you to be willing to make mistakes, be okay with making mistakes, find like maybe the beauty in making mistakes. And like what really matters is not like whether or not you made a mistake. It's more about that you've kept moving forward and like it's more about like where your mistakes got you in the end. So that's your closing words of wisdom.
That was excellent. We are so glad you watched, and we're so excited to make more graphing content and to share it with all of you and to see what you are making also. So we will see you next time. Thanks for joining today.
Graph time, laugh time, math time, graph time. Let's get creative and play with some graphs. Come round the table and we'll do the math. Graph time. with Sara and Sean.